to us about the modern OAuth 2.0. So please welcome him with an applause.
Hi, konnichiwa. So thanks for coming. So I'm going to talk about the modern OAuth 2.0. First, I'd like to introduce myself. I'm Hsiaoming, also known as Lecture. You can find me on GitHub and my blog. Yeah, my Twitter account is also Lecture. I'm a core member in the Paris project. So if you don't know Paris project, you may know Flask. Yeah, Flask is a project in the Paris team. And there is a, you can take a picture and share it in Twitter or Facebook. Welcome to contribute to Flask, OAuth, and other Paris projects. Yeah, please take a picture. Oh, thank you. And share it on Twitter, Facebook. Yeah. Previously, I was working in China in Alipay and Ele.me. Now, I started a small company. Actually, it's just a one-man company myself in Japan, in Koshigaya. So the company has two products. Today, I'm going to talk about. The one is OAuth. OAuth is a Python library in building OAuth and open collective clients and servers. This is why I'm talking about this topic, because I know OAuth well, because I'm writing it, so I know it. So here comes the topic, the modern OAuth 2.0. But what is OAuth? Since you are here, I think you all know OAuth, right? Yeah. OAuth is not a new concept. It has been a while. This is a definition. I think the main point is the OAuth is to enable a third-party client to obtain limited access to the resources on behalf of a resource owner. And take a graph. So, for example, in this picture, a client under the permission of a resource owner, and then the client can request access token from authorization servers. And then the client can use this access token to request resources from the API servers. So the authorization server and the resource server, they can be one server. They can also be several servers. But what is modern? To understand modern, we need a little bit of the history. We need to understand a little bit of the history. So, OAuth was started in November 2006. While Brian Cook was working on the Twitter OpenID implementation, they need a way to have OpenID delegation on the API service. But at that moment, there is no such a solution. So they discussed with some people, and they found, oh, this is a common problem. We need a way to deal with this problem. And then in April 2007, they created a Google group to discuss about this topic. And this is OAuth. And in the same year, in July, the team drafted an initial specification. This is the very early specification. And then in December, the OAuth Core 1.0 was finally released. This is the history of OAuth 1.0. It's not OAuth OAuth 2. So why is OAuth 2? After that, OAuth 1 was introduced into the Internet Engineering Task Force. And after several years, OAuth 1 was finally published as a IFC in IETF, Internet Engineering Task Force. But during that time, in 2009, the OAuth working group was founded. It was created to create OAuth 2 to replace OAuth 1. So this comes OAuth 2. And finally, after several years working, in December 2012, the two documents are published. That is 6749, the OAuth 2 framework, and 6750, that is Barrel token. Both OAuth 1 and OAuth 2, they are actually solving the same problem. That is to enable clients to obtain limited access to the resources. But OAuth 2 is not compatible with OAuth 1. Actually, they are just two different things, very, very different. But I think the most different is OAuth 1 is a protocol, while OAuth 2 is a framework. So what does that mean? A protocol means it's fixed, it's certain, while framework is not. You can build more protocols in the framework, and you can add more things in the framework. That's a very big difference. So OAuth 2 was started with just 2 documents, but nowadays it has many specifications, and that's why I call it modern, because most of the people don't know there are so many things. They just know the original two documents. This is not a full list. Yeah, this one. This red one. Do you know this one? This one is Json Web Token. You can't believe it that this Json Web Token was created by OAuth working group. Do you know that? I'm not going to talk too much about JWT, but here is an example. Actually, JWT has 2 types of JWT. One is based on JWS, JSON Web Signature, and the other one is based on JWE, JSON Web Encryption. Most of the time, we are using the simple one. This is the very basic format of the JWS. It has header, payload, signature. They are not secure. They are not encrypted. Everything in the header, in the payload, they can be decoded with base 64. It's not secure. Just remember. Okay. So here is a full list of the OAuth 2 specification. There are many documents ready for use, and there are some still in drafts, and I think more drafts are coming. You can find the full list on this website. It has so many things, but I'm not going to talk about them all. I just picked 3 parts: the grant types, client auth methods, and token endpoints. First, we'll talk about it later. First, we should know what do we have in Python. Here is some projects in Python. The very first one is OAuth. That is created when OAuth 1 come out. It's OAuth 1. Well, there is a project called OAuth 2, but actually it's OAuth 1. Many people think it's OAuth 2, but actually it's OAuth 1. The other one is actually is promising. It's OAuth Snap. And the last one, yeah, is my project. It's OAuth Snap. Okay, actually, I am also a maintainer of OAuth Snap. This one is BSD licensed. OAuth Snap is a generic implementation of the specifications. It has no framework integration itself. It has no. You can't use it. You can't use it. You need to use some integrations. For example, request OAuth Snap. If you are using Flask, you can use Flask OAuth Snap. Yeah, this one is created by me. And if you are using Django, you can use Django or OAuth Toolkit. This is OAuth Snap. Well, OAuth Snap, yeah, remove the O. It has built-in clients, both with request, Flask, Django. And it has Flask OAuth 1, OAuth 2, and OpenID collect providers. It also has a Django OAuth 1 provider, but it has no OAuth 2 or OpenID collector currently, because I am a maintainer of Flask. So Flask comes first. ごめんなさい. Yeah, I will implement the Django later. But why did I create the OAuth Snap? OAuth Snap is commercial driven. Is driven by commercial plans, because I want to earn money with this project. Also, it's open source. It has a commercial license, and OAuth Snap is community driven, which means I can't control it. I'm a maintainer of the OAuth Snap, but it has many things I dislike when I was creating. So you see, actually I was the creator of Flask OAuth Snap, but it's very hard to write things in OAuth Snap, and it's community driven. I can't change the design myself. Next difference is OAuth Snap just has the core code. It's the generic implementation of the specification, but OAuth Snap has everything in it. Why? Because I want to have a better API design. It's the lesson I learned from OAuth Snap, because I can't create a better Flask OAuth Snap with OAuth Snap, because the API is just not good enough. That's why I created a monolithic OAuth Snap. But maybe in the future I will split them into 3 modules. That's in the near future. And finally, I think OAuth Snap has a very flexible, clean code, while OAuth Snap is not. Let's see. So this is OAuth Snap. Currently, I have I have these specifications in the library. There are more coming, but currently it's just this. So everything is clear, but in OAuth it's not. It just has one specification in this folder, but it actually has several specifications in the RFC 67 line. It has buried token, it has token revocation, it has token inspection, but they are all mixed together. Here is how you can use. It's just a sample code. You can't actually run it. You can have a look. This is very flexible. You can choose which grant you want to use. Okay, now let's talk about grant types. So when OAuth 2 was created, it has four basic grant types: the authorization code, implicit grant type, client credentials, password. Actually, there is a refresh token, but nowadays people don't use that. Let's take authorization code as an example. Sorry, I drew it myself. This is a authorization code grant flow. So when you click the collect in client, maybe application or browser, it will jump into the browser to net the user to allow if you allow this access, it will redirect back to the client and give the client a code, and then the client can use this code to request access token. This is a very basic flow. And then the client can use this code to exchange for token. But it has a problem. So in OAuth, there are two types of client. One is public client, one is confidential client. For example, an application on your device, that is public client, because hackers can decode your application and get the client ID and the client secrets. If it's on the server, it could be a confidential client. So here is why the authorization code flow has a problem. For example, there is a middleman on your device. If your application make a request, and then the browser will redirect back to the client with a code. But since it's a network, it's a network request, the middleman can get this code and use this code to fetch the access token before the client, and then the middleman stole the access token. This is a problem. So we have RFC 7636 to solve this problem. Sorry. So how do we solve this problem? We create a code challenge. Currently, there are just two challenge methods. One is plain and one is this one. It's a hash function. You don't you should use this one, not the plain one. Plain one is just for demos. How could it solve the problem? You say when you want to get the access token with the given code, you need to send a code verifier. The code verifier was generated by the client randomly. So it's in the memory. The middleman cannot know it. And the code change is a code verifier hash value. So it's not decodable. Say once more. So the middleman cannot get the code verifier. The middleman cannot store the access token. This method is only in OSNAP. Other NAPs don't have this function. The top one is the client, and the bottom is the server. I won't talk too much about code. Let's talk one more grant types. We talked about JWT, Json Web Token. There is a JWT profile for OAuth 2. It created a new grant type. Actually, you don't have to know too much about this. I don't have time to talk about this. One thing you may know is, maybe you don't know, is Google is using these specifications in Google Service accounts. If you have used Google Cloud, you will get the JSON credential files, and then you can use that. You can use the Google SDK to get the access token. But if you know what is that, what is the service account, you will find it's just this. So in OSNAP, you can use OSNAP assertion session to create a Google service account yourself. It's very easy. And here is how you could use your grant in the server. Okay, let's talk about client auth methods. Actually, it should be called token endpoint authentication methods. It's too long, so I use client auth methods. This part, when the client wants to get the access token, the client should provide its information so that the server may know what the client is. There are several. For example, in the previous example, you can see there is a basic something is a base 64. This is called client secret basic because it's using basic auth. But there are three standards. It's non-secret client secret basic, client secret post. Here is how you could do with the client secret post. You just put your client ID, client secret in the post payload. If you are using the none is not secure. You will use it in implicit. You will put your client ID, just the client ID, in payload or the URL. But now we have more authentication methods. For example, in the same specification, there are two more client auth methods. The names are not defined by these specifications, but you can find the names in another documents. I won't talk the detail, but it's also available in OSNAP. So you can, this is the server implementation. And actually there is a client implementation. Oh, I missed the slides. And finally, talk about the token endpoint. So you load one certain endpoint. That is the endpoint you can get your access token. But actually, there are more token endpoints. For instance, there is a token revocation endpoint. That is a token endpoint you can revoke the token. And there is a token introspection endpoint. That is an endpoint that you can get the information of your token. There are two specifications. Yeah, they are also available in OSNAP. I won't talk too much about this. So we just talk the three parts of the OAuth, but actually there are more, many more. You can find them on this web page. Oh, one more thing. OpenID Collect is also built upon OAuth 2. It shares the same logic. Actually, I am creating the OpenID Collect based on the specifications in maybe 6.7.49. Yeah. There should be a demo, but I don't have time. So you can write yourself. This is an example. And currently I'm working on the next release. It's 0.10. And thanks for coming. Yeah, Alec, do I have time for questions?
3 minutes.
Okay, do you have questions?
Yeah, we have time for 3 minutes, about 3 minutes for questions. If you have a question for him, please raise your hand so I can give you the mic. Anybody?
Okay, if you don't have question, you can maybe you have one. You can ask me personally. Yeah, you can come talk to me. Yeah.
Okay, well, if there's no questions, then thank you again very much, Young. And in 10 minutes, we will have the next session here by Hideo Hatari, and it's Rust and Python in Japanese. And yeah, let's give another big applause for Yang-san for the presentation.